captain of the Starship Enterprise. Welcome aboard, Captain.
Welcome back to the arcade. Today we're going to be talking about vector games, and specifically Star Trek, which is a SEGA vector game based on the SEGA G80 card rack system, and uses the Electrohome G08 color vector monitor. Okay, this right here, what you're looking at, is the first video game I ever bought. That's right, the very first video game that I ever bought. And I bought this from a local arcade operator, and I bought it on, matter of fact, I still have the receipt. I keep it in the coin box. Here's the handwritten receipt the guy gave me. I paid $350 for it. August 29th, 1986. That's right. I've had this game since 1986. And over the years, it's basically been the same machine. I have made a few changes in it. Most notably, the last major change was it now has a Vector Labs multi-game kit in it, which you can play all of the Vector G80 card-based games. Before that, I had the Clay Cowgill multi-Sega installed in it, which was a fine kit, but it never was finished because he never had time to do the sound card upgrade for it, which is a shame because I love the menu system in it. I have other videos, older videos on this subject, so you can search back and look at them. Okay, well, let's get into it. Okay, well, the main purpose of this video is not to showcase my game, but I'm going to use this game as a test bed to test some Star Trek game boards, the boards that are in my other two Star Trek games, because yes, I have a total of 3 Star Trek vector games. This is, of course, my Asteroids multi game, which is, it was a original Asteroids conversion, and this one was actually routed by the operator back in the day. Probably not very long, but it was used on route. I also have the dedicated upright Star Trek, and also have the Star Trek cockpit, which I guess they call the environmental, but I call it the cockpit, so the captain's chair. So anyway, what I'm going to do here is, I already have this set up to do some tests, and as you can see, I have an empty card cage here. Now, the reason I'm doing this is because the multi-game, the Vector Labs multi-game, uses all of the sound cards from the original games. Now, he makes a multi-sound card which you can eliminate the original sound hardware and use his multi-card, but this was before he actually made the multi-sound, and I sourced all of the boards I needed to make this a complete multi-game. And in order to do that, I have a video on that too, by the way. It's a 3-part series because back then YouTube would only let you upload 15-minute videos. So I had to break it down into 3 sections. And anyway, you have to modify the soundboards and cut traces, cut a trace, add a couple jumper wires. Nothing too hard to do. It's very simple, matter of fact, but
of course, a child could do it. A child could do it.
when you switch it around, it makes it hard to use this to test regular boards. So what I do is I have a spare card cage here, and do is just, the card cage is powered by this 10-pin connector right here, and I just unplugged the one from the card cage in the game, and I'll be plugging this into the one that I have here, which by the way is sitting on the back rail of the cabinet. It has a nice little piece of channel metal here, like this up here, where you mount the kit into the game by just drilling holes through your cabinet and putting bolts in it. Well, this one here fits the wood, so you can set the channel right down on it, and it makes it nice and sturdy. So that's how I set up my temporary test rig here. So then all I have to do is, not even using the original harness that goes to the boards, I have another top here that goes on the card cage. Now this is the kit. Now there are two differences. The kit game has this 44-pin edge connector, which right here, the harness has this 44-pin edge connector that plugs into it. Okay, now if you have a cockpit or a dedicated upright, or the converter cabinet was the same way, unless somebody put a kit in it. I don't know if the kit for the converter cabinet had the 44-pin edge connector, or if it had the 3 Molex connectors like the cockpit and the dedicated upright had. So this is a picture of my dedicated upright, which you can see it has a bracket on the side of the card cage that has these 3 Molex connectors where the harness plugs into them, and then they have cables that come out the other side and go into the card cage, which has the same connectors right here, which actually plug into the boards, into the card cage, and that's how the connections are made to the boards. Okay, with that said, first thing we need to do whenever you're testing G80 boards, whether it's Star Trek or any of the other games, you want to make sure your power supply, which that right there is the power supply and audio amplifier, is combined together in one unit, very similar to the way Atari did with the AR boards. Like I say, it has built-in amplifier, plus it has the power supply. Now that power supply outputs, it has a 10-pin plug, and the other end of this right here, which this one plugs into the bottom of the card cage, the other end plugs in right here to the middle connector, the 10-pin DC output of the power supply. Okay, on this 10-pin connector, the way it goes into the bottom of the cage here, if you're looking at it from the top down, facing this side of the cage, pin 1 is on the left and pin 10 is all the way on the right. Okay, now the voltages on this is pin 1 is an orange wire, and that's the minus 12 volt DC. Pin 2 is a red wire, and that is the plus 12 volt DC. Pin 3 is a white wire. Now that's 3 volt AC, which is the reset signal. Pin 4, 5, and 6 are black wires, and they are ground. Pin 7 is a violet wire, and that's the minus 5 volt DC. Pin 8, 9, and 10 are all brown wires, and all 3 are positive 5 volt DC. So that is the power requirements of the G80 card system. Now, first thing we need to do, now I know that this game works, so I'm not really concerned about the power. I know the power is good. The monitor is good. Here's the G08 monitor up here. I know everything is working, but let's say you got a game that's unknown and you have boards that are unknown and you want to test them to find out if they're good. Well, first thing you need to do is unplug the monitor. You don't need the monitor in the equation. So we're just going to unplug the monitor. This is the power plug for the monitor, which takes AC power, which is center tapped, 45 volts on one side of the center tap and 45 on the other side of the transformer. And that's the transformer, that big transformer down there in the bottom. Okay, well, we're just going to put that out of the way. So now no power is going to the monitor, so we don't have to worry about the monitor blowing up, catching on fire, sparks, smoke, because some people say that the G08 monitor is subject to catch on fire. And it has been known to, but I've had 3 of them for right many years and I've never had one catch on fire. Matter of fact, the only game I've ever seen flames in is my Dragon's Lair, but that's another story. Okay, so now we got the monitor out of the equation. Next thing you need to do is unplug power from the boards. So, you know, you might already have your boards installed in the card cage or whatever. So you don't want to power the boards up until you find out if you have decent power. So next thing I'm going to do is, I done already put a 10-pin plug on here into the Molex, so I can use it as test points to test the voltage. So let me set up on a tripod here. I've already got the ground wire connected. This black wire here is the ground wire that's going to my voltmeter. And I put it on pin number 5, which is right in the middle of the ground wires. There's 3 ground wires. Pin 4, 5, and 6 are the ground wires. So I put it on pin number 5 so that it's no chance of this connector shorting out any of the other power. So that's what you want to make sure is, if you're doing any testing, you know, make sure you're not going to short anything out. All right, let me come right back after I get it set up. Okay, well, I'm all set up here. I got my voltmeter. I have my ground hooked up to pin number 5. And I have my cheat sheet here so I can look at the pinout and see what the readings are supposed to do. So now what I'm going to do is I'm going to power the game up. Now, the game here, since I'm still using the harness in the cabinet, when I cut the power on, the fan that's on the card cage here is going to come on, and the fan actually in the game cabinet is going to come on. Unlike the dedicated games, they all have plugs on them where you can unplug them. And if I could, I'd unplug them so it'd be quieter. But when whoever installed this kit actually soldered the wires to the fan directly up to the power. So short of unsoldering or clipping the wires, the fan's going to run. So just be warned, the fans on the SEGA games are loud. But hopefully you'll be able to hear me because I'm using my wireless mic here, and it won't be too bad. So what I'm going to do is I'm going to go ahead, here's the switch to the game. I'm going to go ahead and cut the power on. And if you've ever had or been around a G80 game, you know the sound of the fans. They do move a lot of air though, so it does help keep the game cool. Okay, so what I'm going to do now is I'm going to zoom in here, and I'm going to hope you're going to be able to see this voltmeter, but I'm going to read out the readings. But I'm going to try to get it in frame here so you can see it, even though the glare might be a little difficult. Okay, all right, pin 1 is up here on the orange wire, and that is supposed to be minus 12 volts. So let me put it on pin 1, and we're getting minus 12.40. That's correct. All right, pin 2 is the red wire. We should get plus 12 volt DC. And there we go, we're getting 12.21. All right, number 3 is the white wire, and that's a 3-volt AC line. So I'm going to skip that for the time being. 4, 5, and 6 are ground, so that brings us to 7, which is the purple wire, and that is minus 5-volt DC. So there we go, minus 5.11 volts. So that's good. All right. Then we have pin 8, 9, and 10, which are all plus 5-volt DC. So here's pin 8. I get it on here. 5.19. Pin 9. 5.19 and pin 10. 5.19. So they're all hooked into the same 5-volt output, so they should be identical, but I'm just gonna, you check them anyway to make sure there's not a break in the wire. All right, now let me change this to AC voltage, and let's go back to pin 3, which says it's a 3-volt AC reset signal, but because there's no load on it, I'm anticipating it's going to be a little more than 3 volts. So let's find out. And yes, it is. It's reading 7.25 AC. So that should be fine though. I'm sure once you put a load on it, it'll probably be much closer to the 3 volts. So there you have it. That's how you check the voltage going from the power supply. Now, you could just pull the plug directly on the power supply and do the same thing, check the pins right on the power supply, but doing it this way, you're checking the power right up to the board where it goes into the card cage, so that just eliminates any possibility of any problem with the harness that goes from the power supply to the board set. Okay, now you might be wondering, well, what does the power plug into down here? It has these 10 pins and the plug goes in to the metal housing. Well, inside the card cage, in the bottom is a PC board with 6 edge connectors on it. I guess we normally call this a back plane. So here is one out of a card cage. And actually, this one has TAC-SCAN written on it. So this one was originally in a TAC-SCAN game, but it's identical. They're all the same. And here is that plug that this power plug plugs into that distributes power to all of the boards in the game. And of course, here's the back. Basically, all it is the power runs off of here and daisy chains and powers to each one of the boards. And these big thick traces right here are the power lines that actually power each one of these edge connectors. So that's what the boards plug into. Okay. All right, now let's take a look at the boards. Well, first, let me go ahead and see if I can get this plug out of here. Probably going to have to get a pair of pliers to get that out. Hang tight. Okay, well, I got my test plug off of the plug here, so I'm going to go ahead and plug this 10-pin connector in. So now we have the power connected to the actual card cage, so we're ready to start testing. So let's take a look at the boards and give you an idea of what they look like. Okay, before we get started with any of the boards, let me just go over some reference material for you. If you're doing anything with any of the G80 boards, first thing you need to do is go to Mark Jensen's website. And I'll try to put a link to his website. Now there are several other places you can find this. So you can do a Google search for the SEGA Gremlin XY FAQ, or Frequently Asked Questions. It's written by Mark Jensen, but make sure you get version 1.17. As far as I know, that is the latest updated version. There are other versions written before this that are out there that have good information and bad information in them. Well, not really bad information, maybe inaccurate information. This is more complete and has the most up-to-date information that you can find, basically. And it goes through, has an introduction, XY converter game system, it goes through the CPU boards, the XY timing and control boards, sound board, EEPROM boards, the monitor, the G80 power supply, gives you a list of the games, Space Fury, Star Trek, Eliminator, Upright Cocktail, 4-player, TAC-SCAN, Zektor. It has repair tips on the CPU, EEPROM, XY boards, audio issues. The list goes on and on. So this is a must. Even if you don't even have one of these games, it's interesting reading. If you're thinking about getting one of these games, I highly recommend to get this and read it. And read anything you can. All the information is valuable, and that's one of the most valuable documents there are. Another valuable document is the game manual. Okay? Now, as far as I know, there are 3, possibly 4 game manuals. I have 3 of them. This one right here is the Star Trek Deluxe Game Kit Owner's Manual. Okay, so this one deals with the kit, which has the 44-pin connector, which goes into the card cage. And there are a few other little minor differences in the wiring harness, but they're all basically the same. Now, another one here is, this one's got kind of a blue cover. The other one is just a standard white cover. This one here has kind of a bluish green cover. This is the SEGA Star Trek Cockpit Owner's Manual. Now this one has everything pertaining to the captain's chair, cockpit version. Even the cabinet parts and the various other differences. Again, mostly the differences is in the wiring harness. Now this has the 3 Molex connectors on the card cage, the same as the dedicated upright. And also I've seen that set up in the converter cabinets, which I think might be the converter cabinets that actually came from the factory that way. I don't know if the ones that they put the kit in had the Molex connectors or the 44-pin edge connectors. I want to say they had the Molex connectors because I don't recall ever seeing a converter cabinet that had the kit wiring harness unless it was one that somebody actually installed a kit into the converter cabinet. But a factory one I think has the Molex. Okay, so that's the Cockpit Owner's Manual. And next is the dedicated upright. Now this one has the side art on it, a representation of the side art that the game comes with. And this one here is the dedicated upright, which has the cabinet and the parts and everything for the dedicated upright. Now, there was a manual I seen on eBay, and because it was on my old computer and I had the motherboard went bad, I don't currently have that hard drive on my new computer, so I don't have access to the pictures I took. I actually bought the manual on eBay, and I don't remember the part number of the manual, but I do remember they had opened it up and it had either supplemental pages in it, or it actually had pictures of the converter cabinet in it. So there may have been a manual for the dedicated converter cabinet. If it is, it's very rare, and I haven't seen many of them. And like I said, I did see that one on eBay. Now the seller was selling 2 Star Trek manuals, and I think what happened was they had either got the pictures mixed up, or when I bought a Star Trek manual off eBay, so they just grabbed one and threw it in the mail, and I got the wrong one. They sent me another deluxe game kit manual, and I tried to get up with them and tell them about the mistake, and I never heard a word back. So that's why I have this extra manual up here. This is actually the manual that they sent me, which is another deluxe game kit. But you can't go wrong with having the extra manual. That way I can just keep these manuals in more of a pristine condition, because this one here was a little ragged in a few pages here. Basically the schematic for the monitor is a little ragged out, but I got plenty of those. But what's nice is it has a complete cabinet wiring schematic, and this is fairly easy to look at and figure out. Although I know a lot of people have trouble with schematics and wiring diagrams and trying to figure out what all the little numbers mean and the codes and all that stuff, and they like to abridge stuff and, you know, like cut it off, and over here they might continue it instead of actually a physical connection to everything. But this wiring diagram is very easy to follow, and if you just study it a little bit, you can figure it out fairly easy. So if you have a game that's incomplete and you need to redo some of the wiring, this is what you need, because if you're good enough to figure it out, you can figure it out with this. And it's just like a road map. Of course, I know nowadays people don't use road maps anymore. They got GPS. You know, it's all automatic. You just plug in your address, it puts up on the map, shows a little representation of where you are, where your car is, and you know, you just drive, and it actually tells you when to turn left, when to turn right, when to go straight. This you have to do it the old-fashioned way, like we used to have to do it with the road maps. Yeah, I'm old enough to where when we went somewhere where we had never been before, we had to get out the old road map and actually know how to read the road map and figure out how we're going to get there. So this is nothing but an electronic road map to your game. So very important, and it's easy to follow if you just sit down and study it. Okay, so enough about the manuals. Like I say, if you have a game, you need a manual. Okay, well, let's get into the boards now. These boards, when they go in the card cage, you can put them anywhere in the card cage you want to. All 6 of the edge connectors that's in the card cage are identical. So you can mix and match where you want to put the boards. It doesn't really matter. But the only thing that matters is whether or not the harness will physically connect to the boards once you put them in the slot. And of course the XY timing board and the XY control board are connected with an interface cable, a ribbon cable, so they have to be right next to each other. So it's just easiest if you got an original board set and you're putting it back in an original game, just go ahead and put it back in the way the factory wanted you to put them in. And this is a little diagram here that I took a picture of that's on the top plate that goes on the card cage. This is the one off of the game kit, which has the edge connector. Well, this was on the other card cage, and it has all of the boards lined up in the cage. It has the PROM board, or the EPROM board, the speech board, XY control board, XY timing board, then the CPU board, and then the universal sound board. That's the way that they're set up, supposed to be set up from the factory in a Star Trek game. So that's what we're going to do. We're going to set them up in this order. So first we need to do is let's get out the ROM board. And this is how I shipped them, and I cut open these envelopes that have bubble wrap in them, and I put the games in them. Okay, this is the EPROM board, or the ROM board, whatever you want to call it. They actually call it the G80 2716 PROM boards. Okay. All right, well, here's the PROM board. So first let me showcase what the boards look like. Okay. All right. Next is the speech board. Okay. And this is what the speech board looks like. And this is the one that produces the digital speech. It says right here, G80 speech synthesis assembly. Okay. So that's basically the speech board. The next is the XY control board and XY timing board. Now, what I like to do is I like to keep these boards together and not unplug the ribbon cable. So what I did is I sandwich them together with a piece of bubble wrap in between them, and I leave the ribbon cables connected to the board. So that's how the ribbon cables connect. This one here plugs into a regular IC socket, and the other one plugs into another IC socket right here. And that's how you set them up. Now, sometimes people hook these up backwards. In other words, the way these are setting right now, they'll have this board on the bottom and this board on the top. It doesn't matter, you know, which one is which. As a matter of fact, let me see what this one is. This one is the XY control board. So actually, if you put it back identical, like the factory said, these are backwards. But it doesn't matter. Just as long as you put them in the same slots, it doesn't really matter. So, I say this one is the XY control board, and this one is the XY timing board. So that's what they look like. Okay. Okay, next we have the CPU board. And if I can get it out of here, it's got some pins on it that poke through the bubble wrap. Okay, now this right here is the CPU board assembly, what they label it as. And that's what that looks like. This one has the header pins up top here that those four connectors, the four red connectors from the top connect to. And this also has the CPU and the security chip, and it has some RAM here. Yeah, these are 2114 RAM. So that's the CPU board. And last but not least, we have the universal soundboard. So here is the universal soundboard. That's what that looks like. And the universal soundboard is used in Star Trek, and it's also used in, oh gosh. That's why it's nice to have this Mark Jensen's thing, frequently asked question. Okay, so Space Fury has its own soundboard. It's Battlestar or Space Fury written on it. Star Trek uses the Universal soundboard. Eliminator uses the Meatball or Eliminator soundboard. And TACScan uses the Universal soundboard. Okay. So TACScan uses the same Universal soundboard as Star Trek. Okay. Well, next thing we need to do is to install the boards into the card cage. Okay, well, let's go ahead and start putting these boards in the cage. And I'm going to put them in the suggested manufacturer's way, the way they came from the factory. We're going to start with the PROM board, or the EPROM board, and that goes in the back of the cage. And what I call the back of the cage is opposite from where the power plug is in the bottom of the cage. So I call this where the opening where the wires go in right here at the top. I call that the front of the cage, and this is the back of the cage. Okay, so let's take the EPROM board here, and you have to line it up in these slots. It's got slots that goes down on the inside. Each board has its own set of slots to help line it up so that it goes into the edge connector, and it also provides a ground for the board, because on each side of the board there's a ground on both sides of the board, and the edge of the board goes in those tracks. So we'll start with the one in the back, line it up in the track. Now, a lot of times these cages, they'll rust up a little bit and they'll get rusty. So before you do this, you might want to, if the game hasn't been running in a long time and it's been setting up, you might want to take that board out the bottom. It's got 4 screws that holds it in. Take it out, clean all the card slots good. You might even check the solder connections on the back, and there's a bunch of solder connections. If any of them look bad, go ahead and solder them. But if they look okay, don't worry about it. Chances are these boards haven't been in and out too many times over the years. And also, while you got the board out, you might want to take a wire brush or something and clean these grooves up, because that'll keep the boards from sliding in nice and easy. Once you got everything clean, then you can hit them with a lubricant, and I just use good old deoxit, because it's a lubricant as well as a cleaner, and you can also clean those card slots with it. So that's if you're having a problem getting the boards to go in and out, because the boards sometimes are real hard to get in and out. Okay, so we just slide the board in and put your thumb on either side and push, and it should click in place. Okay, but like I say, if you don't clean the cage up and lubricate it a little bit, they can be very hard to go in. Okay, the next board that goes in according to the diagram here is the speech board. Okay, so here's the speech board, and it goes in the next slot. Just line the slots up and slide it and click it in place. Okay, the next board is the XY control board and the XY timing board. And I like to put these in together because of the interface cable. It is almost impossible to plug this interface cable in once you put the boards in. It can be done if you do the boards one at a time, but these pins that go into the IC socket are very thin and fragile, and they bend real easy. So I like to put them together while they're on a table, a flat surface, and just keep the boards together. It makes it a little bit more of a challenge to put them in, but all you have to do is just like keep a finger in between the boards, and you can both hold them like this. And what you want to do is just first get one of them started, the back one. And that's probably the most difficult part, is seeing to get them started. Ah, yes. And once you get the first one started, then you can get the next one started. And then once you get them both started, you can just slide them down together. All right. And that is the XY boards. Now, this is a new cable that was sent to me when these boards were sent back to me. I loaned these boards out to Game Fixer to use as a, he was working on a Star Trek board set, so he needed a set to compare. I sent them to him, and turns out a couple of my boards had problems, and he went ahead and fixed them for me, so thank you, Game Fixer, for that. Because when I tested them, they were working here before I sent them to him. So that's the nature of any of these old boards. They can be working 1 minute and the next minute they're not. All right, so this is a new cable. So if you put the top on here, you really should bend it down in here like this. That way the cable won't be rubbing the top of the boards. Okay. Next, after the XY timing and control boards, and I mentioned this earlier, it doesn't matter which one you put in first or second. As long as you put them in together and have the ribbon cables hooked up correctly, it doesn't matter which is which. Okay. All right, next is the CPU board. Okay. So this is the main CPU processor board. The one that has the dip switch settings, and this is the one where those red connectors on the top plate connect to. So that's really the main connectors for the board, as far as these are the for all the controls and everything. Basically, it gets its power from the bottom edge connector here. And also has, this is the reset button, and this is an LED right here that gives you an error code if you have a problem. When you go into test mode, this will blink and blink out any errors you have, but we're not concerned with that right now. All right. Also, a lot of times people like to put this in last, because if you put it in last, you have a lot more space right here and a lot more room for those cables to plug in. But I'm doing it, and you can do it, and that's fine, but I'm going to do it like it came from the factory. So the next slot right here, we'll just put it in. Okay, now that leaves one more board. The universal sound board. This is the one that creates all the Star Trek music and the sound effects and everything but the speech. Now the speech board ties into this board. Well, I think this board ties into the speech board, and then the sound and the speech are mixed together, and then the output goes to the audio amplifier. So sometimes if you have problems with the sound, it could be one of the op amps. Like right here, I think it's one of the op amps that goes bad. And if you have speech but you don't have sound, you might want to check that op amp right there. But anyway, we're just putting the boards in to show you how to hook them up and get them to work and test them. So in goes the universal sound board. And there we have a complete populated G80 card cage, which should be ready after we hook up this top cover here. So the top cover, this is the one again for the kit, and it has the 44-pin edge connector, which the wiring harness in the game has the matching connector right here for it. Now, because of the position it's in, I'm not going to be able, it's not long enough. I could take it out of the wire restraints here and it would reach, but I'm not going to do that because I'm not going to put the top all the way on. I'm just going to leave the top laying open. So for right now, the top goes on this way. So the edge connector goes on the same side as the power plug in the bottom, and this little cutout right here is where if you had the other setup with the 3 Molex connectors, your wires would come out here. But because this has the edge connector, there's no wires that actually comes out of the cage. It all plugs right into this top 44-pin connector. Okay, so the people at SEGA did a good job at labeling all their connectors, and they just wrote it on here with a black Sharpie. So you have P7, P6, P28, and P29. And if you look at the drawing here, you see this is P7, P6, P28, and P29. That's the order that they plug on the board here. So let me zoom in. And we'll go ahead and first we'll plug these in. Yeah. Now this is the reason why a lot of people like to put the CPU board where I put the universal sound card, and that's okay. You can do it that way, and it's much easier. But like I say, I'm going to show you the way to do it, and I'm going to start this end and work my way back. You can go either way you want to, but what you want to make sure is you get all the pins lined up. And when you put all 4 of these pins together, it comes to the exact same number of pins as on the board here. So P29 is on this end. So here's P29. So what you want to make sure is you get it lined up so that you don't skip a pin one way or the other. All right, P28 goes in next. And this one is P6. And last but not least, P7. Now, double check it and make sure you're not one pin off one way or the other. You're not going to have any spaces in between unless you did skip, you know, one on the end or whatever, because when you put all these together, it looks like one solid long pin, which they could have done, but I guess they did it in 4 sections to make it easier to plug in. Because if you ever had to plug a long plug in like that, you know, it's a little bit harder to get all the pins to line up. Okay, so that's the main part of it. Next, we have to hook up these other connectors. And basically what you have is the connectors for the sound and the connectors for the XY board. XY timing board and the XY control board. Now, this one here is keyed, so but a couple of them are not really keyed, and you don't really know. You can put them on backwards, but you really, if you look at it closely, it's really, you shouldn't be able to, but you can force a couple of these, especially the sound ones, in backwards. But I took a picture anyway of the original setup, so it'll be easy to go by to make sure you get the plugs in the right direction. You can look at the color on the plugs. So like this one right here goes in this board right here, which happens to be the XY timing board. Okay, so this one here plugs right in there, and the other one, let's see, plugs in right here, and that one is this plug with the white, gray, and black wires. And if you look at the picture, the white and the black go on this side, so it goes this way, and of course this one is keyed. So no, it don't. The white goes on this side, the gray goes on this end, and the black goes next to the gray. The key is right here, and it's missing a pin right there, so yeah, that one goes in right there. Now you have 2 more plugs here, and this is for the universal sound board and the speech board. All right, so right here, if we look at our picture, this is also labeled P8, and they wrote P8 on the board here, so that's where P8 is. The black wire goes to the outside of the cage. So this one plugs in like this. Now this one goes up here to the speech board, and that one, the yellow wire, goes to the side of the cage. And believe me, it's easy to get these off one if you're not careful. Okay, and that is completely wired up now. So all I have to do now is plug this edge connector in. Now, this edge connector only goes in one way. And basically the way you can tell this is, if you look, the yellow wire is on this end and a black wire is on this end. This end here, this is the cables that goes to the volume control. Well, actually it goes down to the audio amplifier board. So this wire here is going to be on this end, and the yellow and red will be on this end, and the black and a yellow is on the other end. So that's the way it plugs in. So I'm just going to go ahead and plug this in. And that's the way that plugs in. And like I say, I'm just going to let this hang right now because I don't have the wires long enough to where I can set it on top. So now all we got to do is fire it up, right? Well, yes, because we have the monitor unhooked. So if something is wrong with your boards, you're not going to send a stray signal to your monitor and mess your monitor up. Okay. Now what we're doing, since we put all the boards in, we're going to fire it up and we're going to see if the game boots up to see if we have sound. If it boots up with the Star Trek music, that's a good sign. If you don't hear that Star Trek music, then you got problems. And you have to try to figure out what's wrong. Now, you can check out the board set. You don't even need the universal sound board or the speech board in the card cage. You can leave them out, and the game will boot up with just the ROM board, the two XY boards, and the CPU board. But because you don't have any sound, you won't know whether it's really booted up or not. And the only way you can find out is to check the signal with an oscilloscope. You can hook an oscilloscope up to the output, and that's one way you can tell whether your board set is working or not. Now, if you're brave and you think the board is working, you can go ahead and hook it up to the monitor, but I don't recommend that unless you know the board set is actually working. So what we're going to do right now is I'm going to fire the game up with the monitor unhooked and see if we get sound. And that's the first step. So let's power it up and see what we get. Okay, no sound. That's bad. Okay, what do we do next? Well, let's double check and make sure we got everything hooked up right. All right, the soundboard is hooked up right there. It's hooked up okay here. CPU board is hooked up right. XY boards are hooked up right. Okay, first thing you can try is reseating the boards. And I just pulled the connector off of that one. Put this back on. And you know what I think it was? I had this, the reason I had no sound, and this is why you double check. This connector is a, let's see, 1, 2, 3, 4, 5, 6 pin connector. And if you look on the board, the header pin is a 6 pin connector. But it's only 5 pins there. I'd forgot about this. I don't know if you can see that right there. The connector is actually, let's see, 1, 2, 3, 4, 5, 6 pins, but 1 pin has been cut off. The pin on this end is gone, and I lined it up with this last pin, so all these pins were shifted over one row. That's not the first time I've been caught by that. What they should have done, well, it wouldn't have done any difference. But if they had to put a plug in this, I probably could have looked at it and seen, yeah, it's got a plug, and then look closer. But okay, so what you got to make sure is you get it lined up correctly. Let's try that again. Okay, shoo. All right, let's cross our fingers and let's try this again. See, just a little mistake like that will make you think you got a major problem. Let's try it and see what happens. Okay, well, I heard sound, but it was awful low. I might have had the volume down. Let's try that again. Okay, well, I have sound, but it doesn't sound right. I think this is the soundboard that I had problems with. So we can go ahead and put another soundboard in and find out for sure. The last time I tried these boards, which has been almost 2 years ago, and that's how long this game has been sitting here, since I tested a set of boards for another local collector who was putting together Star Trek. And it's been sitting here in disarray that long, so since I'm cleaning the game room up, that's why I'm doing this. Yeah, the last time I fired up one of these boards, and I'm not sure which one it was, had a screaming problem. It just made an awful screeching noise, and it was all messed up. So I don't know if it was this one or the other soundboard I have here. So let me swap soundboards and we'll try it one more time. Okay, well, I've swapped soundboards, so let's fire it up and see if it sounds any better. Oh yeah, that's more like it. Okay, well, now I think we got a complete working board set. If you hear that Star Trek tune, you know the board is booting up. So now comes the real test. Let's find out if the XY boards are working. And since I know the monitor is good, I'm going to go ahead and hook it up to the monitor and we'll see what that does. Now, like I say, if you're not sure about your monitor, or if you're still not sure about the XY boards, if you have an oscilloscope, you can hook an oscilloscope up to it. I have another video, and I'll try to put a link up top here or somewhere in the description that shows how I actually hook the scope up to a set of Star Trek boards. To this, actually, it was to this actual game right here. Okay, so let me go ahead and cut it off, and I'm going to set the other camera up so we can get a picture on the other camera to see what what we get when we turn it on. Okay, well, we're all ready to try it out. The first thing I'm going to do is I'm going to hook the power back up to the monitor. Just plug it in.
Danger, Will Robinson, danger.
Here's the video cable, which is already hooked up directly to the input of the monitor here through the input protection board. This board underneath here, don't worry about that. That's for the multi-game. That's disconnected right now because I had to reset this up as the original game and disconnect everything that goes to the multi-game. So okay, we're all set up. We're ready to go. So let's power it up and find out if we get a picture. or if we get any smoke, flames, and fire. Okay, well, we got a picture, but it sounds like we got white noise in the soundboard. But that's a good sign because the game is booted up and the video looks fine. It's running in a track mode. Let's see. Let's see what happens if I coin up the game.
Welcome aboard, Captain. Entering sector 1.
Okay, the speech board is working fine. But I believe I do have a problem with the soundboard. But the game itself is functioning fine. The XY boards are working.
Entering sector 1.3.
So obviously the ROM board's okay.
Entering sector 1.4. Entering sector 1.5. Entering sector 1.6. Entering sector 2.1. Entering sector 2.2.
Okay, well, let me go ahead and get destroyed. It seems like the sound card has calmed down now. I still got a white noise problem. Okay, so this one has a slight problem. Let me see if reseating the sound card will do anything different. Okay, let me cut it off here. And let's go ahead and see if we can reseat the sound card. I haven't cleaned that connector in this card cage. That could be a problem. And I'm going to go ahead and reseat the speech board too, just because those two are integrated together with this cable right here. All right, let's turn it back on and see what happens. Well, that sounded okay. No, I think I still hear the... No, I still hear the white noise. Okay, so I think that soundboard definitely has a problem. All right, well, let's do this again. Let's go ahead and take this soundboard back out. And we'll put the first one back in, which actually is the soundboard that goes with this board set. And maybe it had a problem not being seated in. It also has quite a few socketed chips on here. And some of these were a little loose. And if this don't do it, then I'll pull these socketed chips out and clean the legs, you know, see if any of them are corroded or whatever. It shouldn't be, because, like I say, these have been stored in these, actually they were in a box, the way they were shipped back to me. And they were, all but one soundboard was working. I think it's been about 18 months ago when I had these out and tested them. All right, plug this back in. And let's fire it up and see what happens. Yeah, it definitely sounds like that's not all there. Let me go around the front, coin up the game, and see what it sounds like. Okay, the coin is up. Yeah, it sounds like it's missing one of the sound channels. The Universal Sound Card has 3 identical
Command of the Enterprise.
Sound
Play
channels.
Star Trek.
And the combination of the 3 channels gives you the full sound. And there's a section in the manual on the Universal Sound Board that gives you a list of, when you put it in test mode, it goes through all the sounds. And if you have a sound that's missing, or a sound that doesn't sound right, it actually tells you in the manual whether it's channel 0, 1, or channel 2, whether that sound takes just channel 0 or channel 1 or channel 2, or if it takes channel 0 and 1, or some of them take all 3 channels. So you can sort of narrow it down as to where the malfunction is on the sound card by using that little chart and figuring out which sounds work, which sounds don't work, and which sounds are halfway working. That way you can sort of narrow down the problem on the soundboard. So obviously I'm seeing some soundboard repair in my future here. So
Welcome aboard, Captain.
okay. Now that sounds okay. Okay, I got no regular thrust. Thrust sound ain't working. Fire sound is working. Photon torpedoes is working. The warp speed is halfway working. Okay. So the soundboard definitely has a problem. Okay.
Entering sector 1.2.
Let me cut this camera off. All right, well, there you have it. Almost a success. Well, now we've pretty much got a working board set here. We still have problems with the universal soundboard, but I can deal with that later down the road. What I wanted to do was just to show you what all these boards for a Sega Star Trek look like, what order they go into card cage according to the factory specifications, and how to hook the harness up to it, and how to properly test the board without causing more headaches than what these XY games already give you, because they're not the easiest things to work on, but once you get into them and get used to them, you'll find out that they're not really that mysterious, and they're not that much different from any other board set, really. Yeah, it's a little different than a Rasta game, but it goes with the vector territory. All right, this particular board set here was working in my cockpit back in 2016. Matter of fact, a little bit before that, you can go look through my videos, and you can actually see a video of me playing the cockpit, and you might want to check that out, because I sort of in costume, let's just say, for the captain's chair. So check that video out if you haven't already seen it. Okay, Game Fixer was at that time, back in 2016 I believe it was working on a Star Trek board set, and he was having trouble with the XY boards. So he wanted to know if I could send him a working set of boards, and I said sure, no problem. So I took these boards, the complete set, out of my cockpit, boxed them up and sent them to Game Fixer, and he was still having problems even with my boards, and he was getting sporadic vectors drawn on the monitor, and even on his scope. So it wasn't a monitor problem. But if you do a search on CLOV, the Killer List of Video Games message board, you can find that thread, and which details the back and forth and what he had to do to fix the boards and all that stuff. What it came down to was he wanted to borrow another set of boards, so I took the XY pair boards out of my dedicated upright. I also sent him the CPU board. Let's see, what else did I send him? And I sent him the universal soundboard, because when I tested that game, my soundboard had developed problems when it was out in the garage. So he said, no problem, send the soundboard, and he would look at it and fix it for me. So I said, okay. So I sent him the two XY boards, the CPU board, and my universal soundboard out of my Star Trek upright. So sending those boards, he found out what the problem was. I don't remember exactly what was going on with it. Like I say, you can research that thread if you want to find out. And basically, he fixed his boards, and he found a few problems on my boards. He fixed both of the soundboards, boxed them up, sent them back to me, and they sit in the box. I never even opened them when I got them back until 2019. A local collector that at the time lived not far from me bought a Star Trek, and he was going to piece a game together, and he had a board stack, and he wanted to know if I would test them for him. So I said, sure, bring them over. So At that time, he brought his boards over, and I set up just like you see right now. Opened up this game, which had the multi-game in it, and I got this card cage out, and we put his boards in and tested them. Then I got my boards out that Game Fixer had sent me, and I unpacked them, and I went through them and I tested those. And at that time, I tested all but the XY pair that went to my upright. I didn't take them out of the package, but I did test the both soundboards and both. No, I didn't send them the CPU board, as a matter of fact, because I just had to get that out of my upright in the garage. I only sent them the XY board and my soundboard, now that I think about it. Anyway, long story short, we tested my friend's boards, and we were able to find out what boards was bad. He sent them off to one of the Star Trek board gurus and fixed the boards, and he got his game working. Okay, then I kind of put these boards to the side and did nothing with them until now. So I got the boards back out. I decided to check them out again and make this little video to show you the process. So anyway, long story short, I know I'm rambling. Let's go ahead and get these boards out of the cage, start all over again, and then I'm going to take the set of boards that goes in my upright, and we're going to do basically the same thing, only this time we're going to do it a little different. You can test the output to the monitor, the video signals, the XY signals. All you need is the ROM board, the XY pair, and the CPU board. So we're going to start with that, and then I'll show you how you can check it with an ohm meter. And if you have a scope, we're going to hook the scope up to it and show you how you can test it with a scope before you hook it up to your monitor. So, with that said, let's get these boards out of here. Mr. Scott, beam up this set of Star Trek boards.
Aye, sir.
All right, thanks to Mr. Scott, all the boards have been cleared out of the cage, and we can start over again. So I'm going to start with, again, the ROM board or EEPROM board, and this is the one out of my upright. So we're going to put that back in the same position. The slot all the way back opposite the side that the power plug is on. Okay. Next, the speech board goes in, but we're not going to put the speech board in, because sometimes if you put the speech board and the universal sound board and you have a problem with either one, it'll cause the game not to boot up, or it'll cause problems. So to eliminate right off the bat, if these boards are unknown, you just leave the speech board and the universal sound board out of the equation. And that'll get you down to just the basic boards you need in order to test and make sure that those boards are working. Then you can go on to the sound board, the speech board, and the universal sound board. Okay, so since we're not putting the speech board in, next we're going to put the XY pair, because you have to have the XY pair to get, of course, any video out. So we're going to put them in the same slots, which we're skipping one where the speech board went. And we're putting these back in the factory slot. Of course, you can put them in any one you want. I keep stressing that because you can, as long as these two boards have to be next to each other. And I'm still not in. All right. Once you get them in the slots, click them in place. Okay, in order to get this to work, we need one more board, and that is the CPU board. So this is the CPU board out of my upright. And in order to make it a little easier for testing, instead of putting it right next to the XY board pair, I am going to put it in the end slot. And that'll give me a little bit more space because we're going to have to get to this pin and these pins here in order to test the boards. But normally it would go in this slot, which would be right next to the XY boards. But for testing purposes, I'm just going to put it like that. Now, okay, now that we got the boards in the cage here, this is the bare minimum you need to check the boards out to see if you're putting a XY signal out that the monitor can use. There are two ways we can test this. One, we can test the XY outputs and the color outputs with a voltmeter to see if it's putting out the proper voltages. There's a certain range of voltages that it has to put out. If it goes beyond those voltages, that's what can cause damage to the monitor because it overdrives the limits of the monitor. So this connector right here, this is the XY timing board that has the 3-pin connector, okay? It's actually 4 pins, but one is cut off because the one that's missing is the key. So the center plug on this, let me zoom in on this. It's this 3-pin plug right here. The center plug is ground, and then either one on either side of it on the outer side, one is the X and one is the Y. I don't remember right offhand which one is X and which one is Y, but if you get it backwards, you can, it doesn't really matter. Even when you hook up the scope, you can just reverse them. It's not going to hurt it. Okay, and down here, on the XY control board, you got the 4-pin connector. And if memory serves me right, if you're looking from this side right here, this pin right here, well, you got 4 pins. One of them is ground. The other 3 is the red, blue, and green control signal that controls the color guns in the tube. So, in other words, whichever pin is the red pin, this signal right here controls the red gun, either cuts the beam off, or it can intensify the beam up to full intensity. So, let's say if it's drawing the XYs or drawing the trace on the screen, and you got this area that, because the trace connects all the dots on the screen. So between 2 dots, if you're not supposed to have any red signal at all, no red line, what it'll do is this red signal will go to 0 voltage and it'll cut the red gun off. So between the point where the red line ends and the red line begins again, when it gets to that other point, then it'll put the voltage back on that line and it'll turn the red gun back on. And if the line is supposed to be a real bright red, it'll go to full intensity. Or it can go, I don't know how many divisions it is in between, but it can control the intensity of that red gun. And same thing with the green and the blue gun. And that's basically how it draws the colors within the XY beam. If all 3 colors are on at the same time, that's when you get your white drawn. So if you have a line that's area that's white, then you'll have the same intensity on all three of the colors. Okay, well, you can test these two by the voltage. It also has a voltage range, as a matter of fact. And I found this in several places, but it's also in the manual. This is out of the manual right here. I don't know if you can see this, but the vertical input to the monitor, which is the output on the board here, so basically the output, the vertical can be plus or minus 3 volts max. So the vertical signal should never be more than plus 3 volts or minus 3 volts. The horizontal signal should never be more than plus 4 volts or minus 4 volts. Now the red and the green and the blue signal, all it says about it is plus 4 volts at full brightness. So it shouldn't be over 4 volts, or if it is over 4 volts, it shouldn't be much over. I don't know how critical that is right there, but I do know the vertical and the horizontal is fairly critical, and so you want it within those ranges. So when we turn the board set on, this is what we're going to be checking for. This is DC voltage. So like I say, the vertical and horizontal, the vertical should be anywhere between plus 3 volts and minus 3 volts. So that's basically how you check that. Now, hooking a scope up to it, well, that's a lot easier. You just basically hook 2 channels up, one to the X channel and one to the Y channel, and then you have to have a scope that has the XY mode. And then when you put it in XY mode, it will just display the XY beam, anything that's drawing on the screen. Now all the lines will be connected, so you'll have all the points to where the lines go to, and then you'll also see the lines between the points that you shouldn't see if you're viewing it on the monitor, because that's where the color controls come in to cut the beam on and off, and to decrease and increase the intensity of the colors. Okay, well, with that said, let's go ahead and hook this up. What should we do first? First, let's go ahead and hook the scope up, and then we'll do the voltage checks last. Now, just using an old cheap B&K 35 megahertz oscilloscope. It's a 1535A, but it does have XY mode. And just using a couple of cheap probes set on 10X. Got these on eBay, a pair of them. They were pretty cheap. So, all right. Well, what we're going to do is, I have these set up because I was using this one time before. Back, if you go back and look at my videos when I was working on the G80 monitor, I didn't know if I had a problem with the monitor or the board set, so I used the scope to find out if the board was putting out an XY signal or if the problem was my monitor. Okay, well, what I did was I just labeled these. These probes come with little color rings you can put on here just to identify them. So I forget what colors it comes with, but anyway, I chose yellow and green just because yellow starts with a Y. So the yellow is set up for the Y signal, so the green is set up for the X. But I'm not 100% sure which one is which on the board right here. I do know that the center pin is ground. So we're going to start with the ground. And scope probe has a little ground wire to it that clips onto the ground. So I'm just going to take another little black jumper wire with an alligator clip on both ends, and I'm going to clip it right to this center ground terminal. And I'm going to slide it down on there so it'll be insulated. The insulation from the alligator clip is now in between the two X and Y output terminals there, so there's no way it'll short out. And the other end here will provide me, I'll be able to hook my ground up to my voltmeter when I get ready to do that. Okay, so the first thing I'm going to do is I'm just going to take a guess. And like I say, it's a 50-50 guess. And it's not going to matter if I'm wrong. All I got to do is switch the probes around. I'm going to hook, let's see, eeny, meeny, miny, mo. All right, I'll probably be wrong. But let me hook this one up to this pin. And get it in here. And let me get the other one. Hook this one up to this one. And I'm not going to worry about the ground on this one because it should be tied in together with the scope here. Okay. Well, let's go ahead and I'll turn the scope on. It should be pretty well set up because I haven't messed with any of the controls since the last time I used this. It's a little bit off. As you can see, the dot should be in the center, but the scope is a little bit out of calibration and a little bit off. So, yeah, it's not going to be perfect. I can dial it in once I turn the game on. Okay, so now we're ready. Turn the game on and let's find out if we have any XY signals coming out of it. And look at there. I even guessed right. I guess today I should buy a lottery ticket. Alignment's a little off. Let's see. As you can see, the control's a little jumpy. I did spray them last time with some deoxit. Let's see. Let's do the gain. Position. Seems like when I mess with one, it affects the other one. Okay, well, that's pretty close. So, now, the easiest way to do it is with a scope. As you can see, we have a decent picture here. Let me zoom in on it so you can probably get a little bit better idea. And of course, it's in a track mode. And because I have no other controls hooked up here, I can't actually start a game. But if I had the controls hooked up here, I could actually go around the front and start and play a game on the scope. But as you can see, without the signals to control the gun, because the scope only has one gun, and you're just displaying what the XY signals are. You see all these lines where all the dots are hooked together? Well, that's because this doesn't have what you would call on the Atari game a Z circuit. I don't know exactly how that would work with the SEGA game. I guess it would somehow work with the color output signals. I've never dealt with it because my scope doesn't have the ability for the Z output. So, but anyway, this is just proof that if you have a scope, you can hook it up. It's very simple to hook up, and you can see that the boards are outputting the proper signal. Now, this doesn't mean that the board is putting the proper red, green, and blue signals. I guess it's possible we can still have a problem to where, you know, the board's not going to be putting out the proper red, green, and blue signals. But since we got the proper XY signals, I wouldn't have any problem hooking my monitor up to it right now and just seeing what kind of a picture we get to see if it did work. Okay, now let me cut this off and let me hook up my voltmeter. Now, first I'm going to hook my ground up. This is ground to my voltmeter. So let me see if I can plug this in somewhere where it's going to grab onto it. All right, that should work there. And now I got my voltmeter on, and it's on DC volts. So that's what we want to do, is DC voltage. All right, let me see if this is going to be in the camera frame. I think we might be able to get by with it. Let me just adjust this camera just a little bit more right here so we can see the voltmeter. Okay, now let's cut the game back on. Now, what did I do with my sheet of paper here? Okay, so the vertical input, and we're going to check the vertical and horizontal input right here first. If you're checking the DC voltage, the vertical should be plus or minus 3 volts. So, vertical, all right, which is vertical and which is horizontal, X and Y? Always get those mixed up. Well, let's just check the Y first, which is the yellow. So we'll just go ahead and touch this pin. All right, and right now we're reading DC voltage. We're reading a negative 0.651 volts. And because it's in a track mode, it's not going to change a little bit, but it's going to do a little bit of variation, but not much. So a negative less than a volt, negative 0.75 of a volt, basically. So that's okay. That signal would be fine. The G80 monitor can handle that signal, no problem. All right, let me go over here and we'll check the green probe, which is the X signal, and we'll touch that, and let's see what we got here. Now this one is a little more active. All right, now this one is showing up because this is an auto ranging voltmeter. I wish I had a voltmeter that wasn't auto ranging so I could just put it on, you know, a regular voltage range, because this is giving us minus 200, well, it keeps fluctuating. Basically a minus 0.46 millivolts, which is less than a half a volt. So that's still within tolerance. Okay, now let's go over here to the color signals. Now, I do know that these 4 pins right here, I don't know which is red, green, and blue, but I do know that this one right here is ground. In other words, if you're going from the edge of the card cage here, this side that way, this one is a color signal, but the next one is ground. So if I put this on the ground, we might get a little, like 1.6 millivolts, but that's still ground. All right, well, let's do the first pin first and see what we get. All right, we're getting 5.44 volts. Now it says full brightness is at plus 4 volts. Now it went up to 6. That seems a little high. Now it's 7.61, so it's varying. Seems a little high, but since it's not hooked up to the monitor, maybe it's going to be a little bit higher. I would still feel comfortable about that. Let's see what the other two ones say. All right, let's go to the next pin. And you want to be careful not to short these out. All right, this one is reading 6 point. Well, it's varying, which it's supposed to do, because the attract mode, you can see what's on the scope there, and it's going to change according to the vectors and the colors that's on the monitor. Right now I got 5.5, 5.1, 5.12. So I would say that's okay. All right, let's do the last one here. And like I say, I'm not sure which color signal it is, but it's either the red, green, or blue. This one is in about the same range, 6.87, jumped up to 7. It's back down to 6.8. So yeah, I would say that's within tolerance. You don't want to see any crazy wild swings like 10 volts or 12 volts or you know, something double the voltage that we're seeing right here. So I would be safe to, feel safe to plug this up to a monitor to see what it's doing. So let me go ahead and shut this down. I'll hook the harness back up, and then we'll plug the G80 monitor in, fire it back up, and we'll see what kind of picture we get on the G80 monitor. Okay, why the Wrath of Khan reference? Well, because things really got fouled up quick. Let me try to explain. In the last video, we just finished checking the boards that were in my upright, and it was bare bones. We just had the ROM board, the XY boards, and the CPU board, and we didn't have the wiring harness hooked up. Just had power going to it. I powered it up, and I had it hooked up to the scope, and it's just like you see it right now. The game is in attract mode, and it's working fine. So it was late that night, so I went ahead and shut everything down and call it a night. Came back out here the next day, and before I set the camera up and anything, I decided to go ahead and save a little time, and I hooked up the wiring harness, and I went ahead and I hooked up the G80 monitor, and I fired the game up just to see if the board was working before I started filming, and it had a beautiful picture. It was running attract mode. Everything was great. So then I disregarded one of my cardinal rules for checking these boards. All right, before I couldn't go any farther because I didn't have the harness hooked up. So I couldn't coin up the game and actually see if the game started to play. So I said, well, let me just try it. So I coined it up. Okay, let me recreate it for you right here. The G80 monitor is unhooked. Right now I just have it hooked up to the oscilloscope. Okay, so it's running in attract mode. So I'm going to go around here and I'm going to coin it up. Coin the game up, and as you can see on the screen, that's fine. So then I decided to hit the play button, player 1. Now, you see what's done happened? It's done locked up, and it's drawing kind of off the screen. You got some movement down here, you got movement up here at the very top, you got this stray line up here, and the vectors are just kind of out of place. Alright, well, it was displaying that on the G80 monitor. So I quickly came around here and cut it off. Everything was fine. But I said, what's going on here? So instead of unhooking the G80 monitor and hooking the scope back up, I went ahead and fired it back up. And when I fired it back up, I didn't get what you see on the scope right here. I got a straight horizontal line across the middle of the G80 monitor. That's right. The monitor went into vertical collapse. So I said, uh-oh. I figured I'd blew the monitor up. So just to make a story a little short here, yeah, I did blow the monitor up. I lost the wide deflection circuit. Okay, well, I got checking, and it's kind of hard to well, let me get the camera off here and I'll show you. Okay, well, here is the in the manual is to monitor the G80 deflection board. Now this is the back of the deflection board where the adjustment pots are, and here are the paddle boards, the current limiting boards, which are called the paddle boards. Okay, this one here is for the X deflection circuit, and this one here is for the Y deflection circuit. Okay, these circuits go to the yoke, the windings in the yoke, one for the X and one for the Y, and they're protected by the fuse right here. Each one's got its own fuse. This one is F700 for the X circuit, and I believe that's 600. Okay, so first, this one right here is the first one you can get to. But at the time I didn't know if it was the X or the Y circuit. Okay, well, here's the back of the monitor. First thing I had to do is, you can barely see in there. So I had to go ahead and take the XY clamp board, which is the original protection board that the output of the board set goes in right here, and then the wires right here run down to the plug that plug into the deflection board. That's how the original is set up. Now this green board right here, that's the BXXYR board for tack scan for the multi-game kit. So we're not concerned about that, but that's attached with the same screws. So I had to take these screws out and remove both these boards so I could get in here. All right, well, I could see the first fuse, which was F700. It didn't look like it was blown, but I could get my meter in there, tested it, and it tested good. So, but the next fuse in there is way back in the back here. So what I had to do is reach in here after I took these boards out. I was able to get my hand in there. I unplugged both of the paddle boards to get them out of the way. And then I was able to get in there with a little screwdriver and pry up on the fuse, and I got the fuse out. Okay, so I got F600 out, and sure enough, F600 was blown. Now I looked the paddle boards over as well as I could, because a lot of times when you have a stray vector, a vector that goes out of its range, that's what causes these paddle boards to kind of burn up. Well, I didn't see any damage on it. That don't mean it didn't have any. So anyway, I got the fuse out and I got looking at it, Now, if you try to find out the value of these fuses, I looked in the manual, not this manual, but the online manual, which I believe is for the dedicated upright. I'm not 100% sure of that. I should have looked in this manual here, but I couldn't find the value of the fuse in the manual, in the parts listing for the monitor. But if you look in the schematic that's in the book, the schematic says it's a 3 amp slow blow. Okay, and I believe on the board, I believe that's how it is, or somewhere, either on the board or somewhere in another manual, it says it's supposed to be a 4 amp slow blow. All right, well, when I rebuilt this monitor, I used, if you're familiar with Bill Boucher, who is a CLOV member, Kill List of Video Games, and he has a website called Bill's Classic Arcade. Well, he has, among other things, Star Trek, and he completely rebuilt it. He did a bunch of research on the parts for the monitor, for the deflection board, all the transistors, the diodes, even the connectors that are used on the thing. He has part numbers for more beefier components. And what he recommends is to, when you redoing and putting these fuses in, to use a 2 amp slow blow. So I looked at the fuse I pulled out of here, and sure enough, I went with Bill's recommendation, and I had put a 2 amp slow blow fuse in here, and I think that's what saved my goose. If it had been a higher fuse, it would have allowed more current to go through the circuit before the fuse blew, and that probably would have took out some of the components on the paddle board. So I went ahead and I put a new fuse in, put the paddle boards back in, and I went ahead and disconnected the G80 monitor, so I didn't try it right then. First, what I did was I hooked it back up to the scope and did what I just did, and sure enough, it had this problem. So then I had to decide what to do next. Now, I didn't film any of this because this video wasn't supposed to be a diagnose or a board repair video. So I just wanted to find out what was going on before I continued with testing the rest of the boards. So I said, well, I wonder if the problem is in the CPU board or the XY board, or maybe even the ROM board. At this point, I figured it could be anything. So what I decided to do was, first I pulled the XY pair out and got rid of that out of the equation, and I put my cockpit XY boards in because we had just tested them and I knew they were good. So I put those in, fired it back up on the scope. It did the same exact thing. So then I went ahead and I pulled the CPU board out, and I put the CPU board in here from my cockpit, which also we had tested good. Put that in, everything was lovely. The game was in a track mode. You could coin it up, hit the player 1 button, the game would go ahead and start playing the game. So then I said, okay, well, now I need to know if I messed up the monitor. So with known working boards, I went ahead and hooked the G80 monitor back up and fired the game up, and the G80 came back to life. So I lucked out this time. That's how easy it is to mess up. It only takes one little lack of judgment. I should never have hooked up the G80 monitor to that board set before I completely tested the game to see if it would actually completely play a game without any problems. So that's on me. So maybe by my mistake, you can learn not to make that same mistake. So that's my story, and I'm sticking to it. Okay. So now what we got to do is, it seems like I got a bad CPU board. I went ahead and what I did, I left my CPU board in here from the cockpit, and I pulled my cockpit XY boards back out, and I put the XY boards from the upright back in here. So I tried it again with the monitor disconnected. I had it on the scope again. So everything is working fine. So the ROM board from the upright is good. The XY boards from the upright are good, but the CPU board was bad. So I did go into a little bit of a testing mode, and I read about the test. It has this little red test button right here. It was with, I put the bad board back in, fired the game back up, and it was just like you seen a while ago. It runs in a track mode, but as soon as you coin it up, it messes up. So I went ahead and had it in a track mode, and I pushed the test button to see if it would go into the self-test. And as soon as I pushed the button, the game locks up. So looking at the in the manual, in the self-test, when you press that button, the first thing it does, well, let me get the manual out and I'll read it to you. Okay, here's the manual. When you push the test button for the basic diagnostic test sequence, number 1, what it does, the CPU RAM. Test all RAM on CPU card before proceeding. System needs to use this RAM for stack and variables during other tests, so if any locations are bad, processor will halt. Halt light will come on. Okay, well, that's what I did. Let's see, let me fire the game back up. And let me cut the lights off here. Alright, as you can see, it's in a track mode now. Now if I press the test button right here, well, first let me get it into the animation again, because in this mode right here, it won't do anything but just freeze. Okay, I'm going to get ready to push the test button now when it does its little Star Trek spinning mode here. Okay, I just pressed the test button. You see what it did? It locked up. Okay, well that tells me right there that it's not going through with the test. So I'm thinking that it could be, this is my working board. It has 4 2114 RAM here, 4 of them. Now it could be that 1 or more of these RAM have gone bad. It could be bad sockets, because the board that's in here now had been out in the game since 2016 out in the garage. So the garage is high heat, high humidity, and in the wintertime it's also very cold out there, so it's a harsh environment out in a unheated and unair-conditioned garage, so could have bad sockets. So let me know in the comments, do you want to see a video of me trying to fix this board? And if so, then maybe I'll go ahead and take that up. I would like to build a test rig so I can be a little easier to do it, but I could probably go through the board and probably change the sockets out. And I have some new ROMs I can put in here, but looks like I'm in the future I'm probably going to buy an Inquisitor so I can test these RAM. And also I was reading through Mark Jensen's repair thread on the Killer List of Video Games, where he had been repairing a whole bunch of these boards, and he says it's a high rate for the Z80 to go bad, so could have a bad processor, but I don't know. I'm thinking it's not, because it does run in a track mode, but right now I'm thinking more RAM, but it still could be socket issues. So just let me know in the comments if you want to see me try to repair the board, and maybe that'll be a future video. Okay, enough of this nonsense. Lesson learned. Let's go ahead with the working. I'm going to put this working CPU back in here so I can finish testing the speech board and the universal sound board, which we already know has problems, but we haven't tested the speech board yet. So let's go ahead and test all of them that we can test and be done with it. Okay, well, now I've put all the original boards from the Star Trek upright, the dedicated upright game. They're all in here except for the CPU board. The CPU board is out of the cockpit. As we know, the CPU board is bad that came in the upright. But everything else is the original upright boards. So I got it hooked up to the scope, and let me make sure that the connections here aren't shorted out. And first we're going to fire it up on the oscilloscope, and if it runs in a track mode and we have sound, we'll go ahead and coin up a game and see if it'll play a game and see if we have speech. And we already know the soundboard is messed up. This is the soundboard that has that white noise in it. A lot of the sounds work, but it has that white noise, and there's a few of them that don't. So that definitely is going to have to go in the repair pile. So all right, let's cross the fingers and fire it up. No pun intended. But of course we're not using the monitor right now, so but you can hear that white noise in the soundboard. Let me zoom in on the scope, and the track mode looks fine, but we know what happened with the other board when we tried it. So let me go around here and coin up a game. All right, now let me push the button.
Welcome aboard, Captain.
Okay, it appears like we have a working game. But of course we still got soundboard problems. And the game ended. And it looks like it's doing okay except for that soundboard. So tell you what we're going to do next. I'm going to go ahead, I'm going to cut this off. And I'm going to plug the G80 monitor back up. Yes, I'm going to do it. This time I feel confident that I've tested everything I can test. So yeah, let's go ahead and hook it up. What's the worst can happen? We really blow the monitor up, right? Okay, so I plugged in the input to the input clamp board. Well, it's actually the board output to the input clamp board. And we need the power wire. Hook that back up. And let's see, do I want to bring the main camera around front, or do I want to use this small camera like I did before and do the picture in the picture? Decisions. Yeah, let me go ahead and put up the small camera so I can leave the other camera here. And if we have any smoke, fire, and flames, maybe we can see it there. So hang tight while I set up. Okay, well, I got it all set up. Now, I got the camera rolling up front, so we should be able to get a picture of the monitor. What you can't see is I have a mirror over here. At least I don't think you can see it. I have the mirror set up and angled so that I can see the monitor from where I'm seated right here. So I can reach down here, flip the switch, and if I see something I don't like on the monitor, I can cut it off real fast. But if something catastrophic happens, more than likely it's going to happen. But I feel confident that with the job I did on the monitor a few years ago, the new cap kit, and went through the whole monitor, that it'll be okay as long as the boards are okay. And I still believe that putting that 2 amp slow blow fuse in that deflection circuit is what really helps to save the paddle boards from self-destructing. Because if the fuse goes first, then it doesn't have time to take out any of the other components. So, but that's not saying things can't happen. Bad things can happen. So, all right, here we go. Will the G80 monitor earn its reputation and go up in flames? Crossing my fingers. Okay, I'm looking in the mirror, the picture looks good. But then again, the picture looked good when I had that other CPU board in. The track mode was working fine. All right, let me go around here and coin up a game, cross our fingers again and find out what happens. Let's see, yeah, looks like I got the little camera in frame there. So let me coin up a game. Hit player 1.
Welcome aboard, Captain.
So far, so good.
Sector 1.2. Entering sector 1.3. Entering sector 1.4.
Okay.
Entering sector 1.5.
Looks like the only problem we have again is the soundboard.
Savagely answer. Entering sector 1.6. Entering sector 2.1.
Okay, I'm going to get killed. I'll do another video playing the game, but as you can hear, it still has that white noise. Hopefully that's not going to be too much of a problem with that soundboard. Now, another thing I've noticed, it looks like on this particular set of XY boards, the screen is sort of a little bit too wide, so you can adjust that as 2 pots on the XY timing board, I believe it is. One of the XY boards has 2 like 10 turn pots or whatever, so you can adjust those pots that will adjust the X and the Y position, so without messing with the monitor. The monitor is pretty much preset at factory, and this monitor hasn't been touched in a long time. And this monitor with my multi-game is set up like it's supposed to be, so this is an adjustment on the game board, but I will do that when I put it back in the original upright cabinet, because it could be that that monitor has been adjusted for this particular pair of boards. So just another one of them little things. Okay, let's put it in test mode and see what we get as far as sounds and everything. Okay. And that's their attempt at color. You can't really adjust much to it. All ROM's good. Okay, here's the sounds test. Okay, we got white noise at the end of phaser. Photon sounds okay. Targeting it, I think that's okay. Deny is okay. Shield hit is okay. Enterprise hit is okay, but the white noise comes back. So that could be a key as to the explosion. Same thing. Same thing, white noise. Dock is okay, no white noise behind it. Starbase hit has a white noise behind it. Starbase red is okay. Starbase explosion has white noise. Small bonus I believe is okay. Large bonus okay. Starbase intro has the white noise. Klingon intro has the white noise. Enterprise intro has the white noise. Player change is okay. Klingon fire is okay. Impulse I think is okay. Warp is okay, I believe. Red alert's okay. Warp suck is okay. Saucer exit is okay. Nomad motion is okay. Nomad stop is okay. Okay, that's got white noise in the whole thing there. That's got white noise in it.
Command of the Enterprise. Play Star Trek. Be the captain of the Starship Enterprise. Welcome aboard, Captain. Congratulations. High score. Press player 1, start. Press player 1 or player 2, start. Damage repair set.
Okay. So it passed the self-test. The only problem we have is with the soundboard. And of course that CPU board. But, okay. Go ahead and cut this off. All right, well, I'd say that qualifies as a partial success anyway. Well, really it's 100% success because I could have fried the monitor, but I didn't. I averted disaster. So maybe the vector gods were on my side this time anyway. But got to look out for that wrath of Khan. When he gets angry, he gets angry. Okay, well, this is going to wrap this video up. I know it's a long video, and I appreciate anybody that stuck with me and is watching this right now, because I know a lot of times, you know, especially if you're not interested in this type of thing, you know, you watch a couple minutes and say, nah, this ain't for me, and just don't watch it. But the ones that really are interested in this and can put up with my rambling, I appreciate your viewership, and especially appreciate it if you have subscribed to my channel. And if you haven't subscribed to my channel and you're still watching me at this point, there's no reason not to subscribe, because I'm going to have some other stuff coming up, and I'm going to have a variety of stuff. So like I said in one of my other videos, and I didn't get any feedback. I'd like to get some feedback, but I don't know if anybody is watching to the end, and if they don't see it, they're not going to hear. So they're not going to be able to give the feedback. So I want to know, what kind of content do you want to see? Do you want to see me repair some Star Trek G80 boards? Do you want to see if I can figure out what's wrong with the CPU board? Do you want to see if I can figure out what's wrong with the universal sound board? You know, I can split this up and have the CPU board as one video, and each soundboard as a separate video, and unless it turns out to be something simple. But I really want to get a project in this summer before the summer is over, before you know it, summer's going to be over. Okay, enough of the rambling. Finally, the end. This has just been another arcade fix. In a way, have you had your arcade fixed today? I did break the monitor and fix it, so even though it was a fuse.